And this is something I'm going to change around. Okay? So all I have to do is, this is basically the equation for CAPM, right? These are the inputs. Let me insert a note here. These are inputs of SML. If I knew what risk-free rate was, I could have calculated expected return. In this case, my target is 13.6. That's the difference between my target and what it actually is. I'm going to ask Excel to solve this equation by saying, do a what if analysis goal seek, make the difference 0 by changing what I don't know. Done. That's civilized way of doing algebra. Again, I have no preference how you do it. If you're comfortable with doing this algebraically by hand or symbolically, that's fine. But however you solve that equation for RF is your business. And to me, this is much more civilized. And I'm a surgeon with algebra. I can do that algebra in my head. I still prefer this one. Why? Because I'm less likely to make an error. As you can see, I made an error here because I put the inputs wrong while I was calculating it. Here, all you have to do is change the inputs and do it again if you get the inputs wrong. So this is solving for RF. Not solving, solving. This is all right. You have a portfolio that invests 22% in A, 36% in B, and remainder in C. The expected returns are these 9.7, 14.5, and 11.5. What's the expected return of the portfolio? Well, expected return of the portfolios are weighted sum of, actually average of, individual expected returns. So in this case, weight of A is 0.22, weight of B is 0.36, weight of C has to be 1 minus weight of A, weight of B, which is 56, 58, 42. Okay? Hence, expected return of the portfolio is weight of A, expected return of A, let me calculate it here, but I'll also do it on Excel. 0.22 times 9.7 14.5 1206, rounded to 2 digits. Or alternatively, if I wanted to do that in Excel, A, B, C, weight, these are all my inputs. Since weights have to add up to 1 minus some of the remaining ones, and portfolio expected return is simply some product of the weights with the expected returns. Either way works. It says the stock of New Air has an expected return of 16.7%. Risk-free rate is 4.2, and market risk premium is 9.5. What is the beta of the New Air stock? Let's remember the expected return is risk-free rate plus beta times market risk premium, right? Hence, market risk premium is expected return minus RF divided by, not market risk premium, I'm sorry, beta. I'm not going to do this in Excel because it's straightforward enough. So in this case, it will be $132. And you can always check if you plug 132 in that equation, you should get 1674 as the answer. All right. Copy. You have a stock that has a beta of 1.1, expected return of 1244, and it does lie on the security market line, which means it's correctly priced. A risk-free asset is yielding 3.2%. You want to create a 15,000 portfolio that is comprised of these two securities, which means security A and risk-free stock, risk-free asset, that will have a portfolio of 0.7. What is the expected return on this portfolio? Well, beta of the portfolio is beta of A times beta of A plus beta of risk-free asset times beta of risk-free assets, correct? What is beta of risk-free assets? By its very definition, 0, right? So beta of A is already given to you. Oh, yeah, it's given to you, 1.1. So I want beta of portfolio to be 0.7. That's the rate I need. If that's the case, the entire portfolio will have a beta of 0.7. And what is the expected return on this portfolio? Well, market risk premium, right? Now, we know this. That's 3.2. We know the beta 0.7. We just need to calculate market risk premium. And we're going to calculate that using this. Remember from here, where are you? Didn't we do something like this? Market risk premium is equal to the expected return minus risk-free rate divided by the beta for any asset. Well, this is for asset A. The expected return was 1244. Risk-free rate 3.2. Come on. Okay.